Check it.
Okay, welcome back. Today we're going to be adding and subtracting fractions. Now in the last section we were multiplying and dividing. Today we're going to add and subtract. Before you can add two fractions, you need to find a common denominator. You might remember that from middle school. And the way you find a common denominator can actually be formalized in the way that I'm going to show you right now. It's in case you've ever been foggy about how do I choose a common denominator. And one of the ways that people do it is by multiplying the denominators. Like for instance, this example down here, you might just multiply the 3 and the 4 and get 12. And that works sometimes. You can sometimes just say, all right, well, a common denominator for 3 and 4 is 12. That does work. But sometimes when you multiply the two numbers, you get something that's too big. For instance, you have 15 and 20 here. If you just multiply those, you get 300. Now, surely there's a smaller denominator than 300 that would be the least common denominator. So that's going to be the idea here. How do you find the least common denominator when you have two fractions without just multiplying the denominators? Because this gets really big. Like for instance here, 160, you don't want to have 600 as your denominator. That's just way too big. So how do you choose a common denominator? And the way to do this is to find what's called the least common multiple, LCM. And now, what the least common multiple is what number they have in common that could be used as a denominator, as a common denominator. So least common multiple, this is going to be the focus of today's lesson, finding that, and then using that as your common denominator, okay? So let's get started here. The way to do this, the way to find a common denominator for all these questions is to look at the factors of the denominators. So what are the factors of this denominator here? Well, this is 3. So it's just 3 and 1. Now we're going to ignore 1 as a factor because 1 is not useful to us. So the only factor here is just 3. Okay? Now for 4, the factors are 2 times 2, right? So we want to get down to prime numbers, prime factors. So 2 times 2 is 2 squared. And what you do is you look to see if they have anything in common. This is a 3, this is a 2, nothing in common, so just multiply them. And that's why you only multiply these. You don't have to do anything else because they don't have any factors in common. So now you ask yourself, all right, what do I do to this 3 to make it a 12? I multiply it by 4, so I do the same thing to the top. If I multiply the bottom by 4 to get 12, I multiply the top by 4 to get 8. And what do you do to a 4 to make it 12? You multiply it by 3, so you do the same thing to the top here and you get a 9 here. Okay, this is all 5th grade, 6th grade stuff here. And you get to 17 over 12. Okay, and we don't do mixed numbers, so we'll leave it as an improper fraction. In algebra, improper fractions are proper. But now coming down here, will we just multiply 15 times 20? Not so fast. There actually might be a number smaller than 300 that would work here. So once again, let's look at the factors of 15. 1, 3, and 5, right? 1, 3, 5, and 15 rather. So we want the prime factors only, prime. Okay, 15 is not a prime number. It has factors. But 3 and 5 are the prime factors. So let's just list those. We have 3 times 5. And then what is 20? 20 is 4 times 5, but we need prime factors. 4 is not prime, so it's 2 times 2 times 5, or 2 squared times 5. Now you notice they have a 5 in common. We don't need to use the common factor more than once. So here's what we do. You're going to take one of each factor only. So we'll take a 3, we'll take one of the 5s, and we'll take the 2 squared. So 3, 5, and 2, we're not going to use this factor here. So instead of getting 300, we should get something substantially smaller. Well, actually 5 times smaller, all right? Which is going to be 60. So now this is how you find your common denominator. You're going to multiply all the unique factors. 3 times 5 is 15. 15 times 4 is 60, and you're going to get 60. And now there's your common denominator for these two fractions, okay? And that's your least common multiple is 60, so your common denominator is also 60. Now, what do you do to 15 to get to 60? You multiply by 4, so multiply the top by 4, this becomes 12. What do you do to 20 to get 60? You multiply by 3, so multiply the top by 12, you also get 12. And what we get here is 12 plus 12 over 60, which is 24 over 60. And you can reduce that. There are actually some common factors here. So how do you reduce it? Once again, go, factor out the 24. So 24 is 3 times 8, and 8 is 2 times 2 times 2. right? So 2 times 2 times 2 times 3, that's 8 times 3 is 24. And 60 is 15 times 4, one way to look at it. So that'd be 3 times 5 is 15, and 4 is 2 times 2. And you just cancel out the common factors. Like that. And what you get is 2/5. Okay? Now, so let's go on to this next example here. Let's find the least common multiple of these three polynomials. Okay? So we have 6xy, 15x squared, and 9xy to the fourth. Now for the numbers, you want to write them as prime numbers, but for the letters, you can leave the letters alone. So the 6 becomes 2 times 3, and then xy. The 15 is 3 times 5, and then you have x squared. That's that one there, that's that one there. And then this is 9xy to the fourth. This is going to be 3 squared xy to the fourth. So factor the numbers like we did in the last example. Factor those to prime numbers. And then the letters, just copy them down. Now look at every factor here and say, what do they have in common? Well, we have a 2 here. It's the only 2, so we have to use it. So box that 2. We have a 3 here, we have a 3 here, we have a 3 here. We're only going to use one of the 3s. We're not going to use repeated factors here. So which 3 should I use? Well, this is 3 to the first power, this is 3 to the first power, and this is 3 to the second power. Use the highest power. So we'll use this one, 3 squared. 5, there's only a single 5, so we'll use that 5. Okay, so that takes care of the numbers. Now the letters. There's an x here, an x squared here, and an x here. We're only going to use one of them. We're going to use the one with the highest power. So we'll use this x squared right here. And then y, there's a y here, there's no y here at all, and there's a y to the fourth here. Well, we're going to use just one of the y's, the highest power one, this one right here. We're going to find the least common multiple. The LCM in this case is the 2 times the 5 times the 3 squared times the x squared times the y to the fourth. The things we put in the boxes are what you're going to multiply, and that's your least common multiple. So this is 9 times 5 is 45 times 2 is 90. X squared, y to the fourth, and that's how you find the least common multiple of an algebraic expression instead of a 6th grade fraction. We're going to find the least common multiple of two polynomials. Now, what was the logic we used to find least common multiples? I said factor all the way down until you can't factor anymore, to prime numbers in other words, and then look for unique roots, unique factors, and don't repeat. So we're going to do the same thing here. We have two polynomials. We have this thing, and we have this thing, and they're both factorable. So we're going to factor them. Well, you're looking at this and saying, all right, how do I factor that? Well, remember, the first thing you always look for is a GCF, and this has a greatest common factor. There's a y in all of these, right? In fact, there's a y squared in all of these. So pull the y squared out, and you get this, y squared times, and now what's left in here? Y squared, 8y, and 15. Now you look at this and say, hey, I can still factor that, right? Reverse FOIL for that. Okay, so remember, pull out your GCF before you do anything else, and that'll expose a much easier factoring problem. So this is just reverse FOIL, y and y, two numbers that multiply to give me 15, they add to give me 8, 5, and 3, right? Both positive. So that's fully factored form right there. Let's fully factor this now. Well, this one's just going to be reverse FOIL, y. Two numbers that multiply to give me 40, that add to give me 3, 8, and 5, right? The bigger number is negative. So if you add together negative 8 and 5, you get negative 3, and if you multiply them, you get negative 40. So that works. Okay, we have all our factors now. So just to relate it back to the problems we did before, you write out all your factors, right? And you start boxing one of each kind of factor. Well, we're doing the same thing here. Here are your factors, right? And we look at it. We have a y squared, that's one kind of factor. We have a y plus 5, that's one kind of factor. We have a y plus 3, a y plus 8, and another y plus 5. So clearly we're not going to use both y plus 5s. We're only going to use one of them. Okay, so start boxing stuff. Is there another y? No. So just take that y. Y plus 5, there's two of them. So if one of them was like a higher power, you'd use that one, but they're both the same thing. They're both just y plus 5, so box one of them. Y plus 3, there's no other y plus 3, so we have to take that one. Y minus 8, there's no other y minus 8, so we have to take that one. Okay, and this one is a repeat, so we don't use it. So what's our least common multiple? It's everything that's in the boxes here. Just multiply all that stuff. So you get y squared times y plus 5 times y plus 3 times y minus 8, and you're done. So if we were adding two fractions where these were the denominators, this would be the common denominator. And I know it looks crazy, but it's pretty simple to get. Let's try this one. This is a monomial, meaning one term each instead of polynomial. All right, what's the least common multiple for these two denominators? Okay, we want to add these two fractions. We need to find the least common multiple. So what we'll do is factor out the 2x to the third as much as possible. I'll do it over here. Well, 2 is already prime and x to the third is already factored. And then 8xy squared, 8 is actually 2 times 2 times 2, right? So 8 is 2 to the third xy squared. So we need to take one of each factor to get the least common multiple. Well, there's a 2 here, and there's a 2 to the third here. Choose the one with the bigger power. That's the only 2 I'm going to box. There's an x here and an x here. Just choose the one with the bigger power. So that one there. And there's only a single y, so you have to take it. So what's my least common multiple? It's 2 to the third, which is 8, x to the third, y to the second. That's going to be my common denominator for these two fractions here. So take your two fractions here and write that new common denominator down there for each one. Okay? Now the question is, what do you do to this denominator to make it this denominator? And whatever you're doing to the bottom, you must do to the top. So to get from 2 to 8, I have to multiply by 4. So this 3y, I have to multiply by 4 and make it, well, you know what? I'll just do it this way. I'll write 3y, and then here's the 4. How do I go from x to the third to x to the third? I don't do anything. How do I go from nothing to y squared? I have to multiply by y squared. Okay, so the red stuff is what you're tacking on. All right, how about this fraction here? How do you go from 8 to 8? You don't do anything, so leave it alone. How do you go from x to the third power? You need to multiply by x squared. So the 5z is already there, but now we're going to multiply by x squared to get from this x to this x. And then how do we get from y squared to y squared? We don't do anything. Okay? And now we can make one big fraction out of this. So here's the common denominator. And we're just going to multiply, simplify these and put them on one fraction. So this now becomes 12y to the third. Okay, because y squared times y is y to the third, and 3 times 4 is 12, plus 5x squared z. And since these aren't like terms, you're done. Just box your answer. Let's take a look at their answer. Yep, same thing. So let's try this one right here. What's the least common multiple for these? Well, 16b squared. 16 is 4 times 4, and every 4 is 2 times 2. So 16 is actually 2 to the 4th power. So instead of 16, I'm going to write 2 to the 4th power. And then we have b squared. Remember, you have to have prime. All your numbers have to be prime for this. And then for 5a cubed b, well, 5 is already prime. So 5a cubed b, you don't have to do anything. Let's pick one of everything. Well, there's only a single 2, so I have to take it. There's only a single 5, so I have to take it. There's only a single a, so I have to take that. There are two b's, but one of them is b to the first power and one of them is b to the second power, so take the higher power of the two. So what's my least common multiple? It's 5 times 2 to the 4th, which is 16. So 5 times 16, and then you have a a to the third b squared. 5 times 16 is 80, a to the third b to the second power. Okay? That's going to be our least common multiple and our common denominator for these two fractions. So let's write out the subtraction here with the new denominators. Okay, 80, a to the third, b squared. Now, what do I do to 16 to get to 80? I multiply by 5. So whatever I have on the top here, 3a squared, I'm going to multiply it by 5. What do I do to this denominator to get this a to the third? Well, there is no a here, so I need to multiply that by a to the third. And then what do I do to b squared to make it b squared? Nothing. It's already b squared, so I'm done there. How about here? What do I do to 5 to make it 80? I multiply by 16. So I already have an 8x up here. I'm going to multiply it by 16 also, because 5 times 16 is 80, so 8 times 16 is going to happen up top. I already have an 8 to the third power, so I don't have to do anything with the a's, but what do I do to this b to make it a b squared? I multiply by a b. So now I can make one big fraction, 80 a to the third b squared. This right here is 15 a to the 5th minus, and this right here is 8 times 16 is 80 plus 48, 128, bx. These are not like terms on the top, so I cannot add them, so just box your answer. Okay, one last example, and we'll call it a day. So we want to add these two fractions here, and these are polynomials, so we have to fully factor everything before we start. So let's see, we have 5 over. Now this doesn't, you can't factor this, it's already linear, but you can pull out a GCF. So that's the only factoring you can do there, is pull out a 6, and this becomes 6 times x minus 3. Now minus, the top here is x minus 1. The bottom here has a GCF. You can divide them all by 2, right? Not by 4. You divide them all by 2. So if you take a 2 out, just do this on the side here, you get 2x squared minus 7x plus 3. And the thing in here, well, unfortunately, we're not going to be able to reverse FOIL this. So it looks like we're going to have to use the AC method. Now, if you remember how the AC method works, so there's going to be a 2 here, right? So that, I just took care of that. So let's just get rid of that 2 and just put it over here so it won't get in our way. So what you do is you take the A times C, you multiply this times this, and you say AC is 6. So you need to find two numbers that multiply to give you 6 that add to give you negative 7. And that's going to be negative 6 times negative 1. If you add those together, you get negative 7. And if you multiply them, you get positive 6. So that works. And if you remember how the AC method works, you take this middle term here and you split it into negative 6x and negative 1x. So this is still 2x squared. This is still 3. And now you factor by grouping. Just look at the first 2 terms and the last 2 terms and factor by grouping. That's how AC method works. It turns a trinomial into 4 terms so that you can factor by grouping. So what's the GCF right here? Well, you can definitely take out a 2 and an x from both of those, right? Leaving you with x minus 3. And now if you remember how we do this, the other parentheses here has to be x minus 3. There's no way around it. These have to match, otherwise AC method is not working. So you ask yourself, okay, if this has got to be x minus 3, what number would I put here to make this true? It looks like negative 1, because negative 1 times x is negative 1x, and negative 1 times negative 3 would give me positive 3. And then you can say, all right, well, the factors are 2x minus 1 and x minus 3. Okay, the x minus 3 here is right there, and the 2x and the minus 1 is right there. So that's what's going to be right here. 2x minus 1, x minus 3. So there we go. That's fully factored. That was 3/4 of the battle there. Okay, now we're going to find a common denominator now, least common multiple, and put it for both fractions. So what is the what do you call it? Least common multiple here. Well, we'll do that, I guess. That was the factoring. Let's find the least common multiple over here in the margin. We have a 6, which is a 2 times 3, right? And then we have x minus 3. That's the prime factorization of that. And then for this, these are already kind of factored already. There's 2x minus 1, and x minus 3. We're just going to grab one of each. So there's a 2 here, and there's a 2 here. We're only going to grab one of those. And they're both power of 1, so it doesn't matter which one I grab. I'll just grab that. This is the only 3, so I have to grab it. This is x minus 3, but there's another x minus 3 over here. So I would grab the highest power one, but they're both the same power, so I'll just grab this one here. This one here, I've already got a 2, I don't need it. I've already got an x minus 3, I don't need it. But this is the only 2x minus 1, so I have to grab that. So what's that going to be for my least common multiple? The LCM is going to be 2 times 3, which is 6. And then you have x minus 3 times 2x minus 1. That's going to be our common denominator for both of these fractions here, right there. That right there is going to be what we're going to put here and here. Okay. So now you do that same thing we did before, which is ask yourself, how do I go from here to here? How do I go from 6 to 6? I don't do anything. How do I go from x minus 3 to x minus 3? I don't do anything. But nothing to 2x minus 1, I need to multiply by 2x minus 1. So there's a 5 already up here, but I'm going to multiply it by 2x minus 1. Then you have your minus. Here, there's already an x minus 1, so put it there, put it in parentheses, because we're going to have to multiply it by stuff. How do I go from 2 to 6? I have to multiply by what? By 3. How do I go from x minus 3 to x minus 3? I don't have to. Or it's the same thing. And this is also the same thing. So really, I'm just multiplying by 3. I'm done. Okay. So we've got everything done. We can make one big fraction now. Here's our common denominator, which we leave in factored form. We will simplify the top, however. So let's go ahead and simplify the top. We'll distribute. This becomes 10x minus 5. And we can distribute this as well. This is going to be minus, that's a minus from here. And this is going to be 3x minus 3. So be careful because you need to distribute that negative. So 3x minus 3, don't forget to group these together here. So it's this thing minus this whole thing here. So you need to group that. And the way you subtract is to distribute the negative and add, right? So the denominator is already done. We can just copy that. This is going to be 10x minus 3x, which is 7x. And it's going to be negative 5 minus negative 3, which is plus negative 3. So negative 5 plus 3 is negative 2. And there we go. We are done. Okay, that's it. See you at the next one.
Check this.